the aftermaths of war, when Britain was a veritable arsenal for the Allies, is the disposal of a vast quantity of unused and dangerous ammunition. Look out when you see one of these signs. Much of the ammunition is taken to sea for disposal. And once again, the faithful LST is on the job. Already, 300,000 tons have hit the briny or have been blown up. But there still remains a gigantic stockpile of 800,000 tons to be liquidated. In the wake of war, Britain has one of the world's biggest house-cleaning jobs.
Hello and welcome. The video you just saw was shot post-World War II, and it shows soldiers disposing of ammunition by just dumping it straight into the ocean. This is just one of many instances where throughout history, we have treated the ocean like a dumping ground for our waste. Until recently, the phrase, "the solution to pollution is dilution," kind of summed up our approach to disposing of waste and hazardous materials. The ocean, in all its vastness, seemed like it could provide a limitless safe repository for waste, and all that water would just dilute the toxins, rendering them harmless to the environment, organisms, and humans. Unfortunately, researchers are starting to realize the negative consequences of using the ocean this way, and overall the hazards of marine pollution, which is the focus of this lecture. Let's take a look at what we mean by marine pollution. So your book describes marine pollution as the introduction of substances or energy into the ocean that either changes the quality of the water or affects the physical, chemical, or biological environment. So this is affecting the critters in the ocean. And so specifically, a pollutant is any substance that interferes directly or indirectly with the biochemical processes of an organism. And that includes us, humans. Researchers that study marine pollution are often trying to minimize the harm of a given pollutant. So there's a couple things that they're going to take into consideration when they're evaluating how harmful a pollutant is. First, the quantity. How much of this pollutant has actually entered the ocean? Second, the toxicity. How harmful a given amount of that substance actually is. You can think of this as how potent is this particular toxin or pollutant. Third is persistence. How long is this pollutant going to remain in the environment? Is it going to stick around for a matter of minutes, or is it going to remain there causing harm for hundreds of years? One thing to keep in mind when we're evaluating persistence is asking, is this pollutant biodegradable? And a substance that is biodegradable, it can be broken down into simpler, which are often less harmful compounds through natural processes. All right, now let's look at a few common pollutants. I'm going to introduce them here and then we'll go over them in a little bit more detail. The first is petroleum or oil. We've all seen oil spills on the news, and although this is a resource that a lot of us depend on, it also can be harmful to the oceans. Second are synthetic organic chemicals. Now, these are chemicals that are manufactured to be similar to a lot of organic chemicals with carbon and hydrogen, but these often have a much longer staying power than their organic counterparts. Heavy metals. These are several elements that you might recognize from the periodic table that can be harmful, such as mercury, lead, arsenic. And then finally, plastic, something we use every day, but unfortunately makes its way into the oceans. So this is by no means a complete list of marine pollutants, but these are 4 common ones that we are going to focus on. So let's start with petroleum, and specifically oil. So petroleum is a marine resource, but when that oil enters the marine environment, it can have some harmful effects to the organisms there. If there's enough oil, say in the case of an oil spill, those marine organisms can become actually coated in oil, like this poor pelican in the picture here. When that happens, their feathers or their fur, they're no longer able to provide that insulation that the organisms need. And also, with the case of birds, they can lose their ability to fly because they're coated with so much oil. There is a happy ending for this pelican here. It was cleaned up by crews who were cleaning up the oil spill. And interestingly enough, Dawn dishwashing detergent is the preferred substance to use to clean up these organisms. So go Dawn. Okay, another harmful effect comes from something called polycyclic aromatic hydrocarbons, PAH for short. And these are small components of petroleum, but they are toxic in small amounts. These can cause sickness in organisms, it can reduce fertility rates, and what's unfortunate is a lot of times these effects are delayed, so we don't realize that this has actually happened until down the line a little bit. Okay, some good news. Hydrocarbons, petroleum is a hydrocarbon, meaning it is made up of chains of hydrogen and carbon. They are biodegradable. And so what that means is with time, that oil is going to break down into substances that are less harmful. There's some experts that will actually argue that oil in the marine environment is one of the least damaging pollutants long term because it's biodegradable. Now let's take a look at where this oil that enters the marine environment is actually coming from, because some of it is a bit surprising. All right, to the right, we see a couple pie charts that are showing us where this oil is actually coming from. And this first one is showing all the oil in the marine environment. And what's surprising about it is that about half of that oil that enters the ocean is coming from natural sources. So this is coming from something called an oil seep that is on the ocean floor, where some of that oil that is typically trapped in the ocean crust is being released through these seeps. These are processes that have been occurring for, in some places, millions of years. Now, roughly the other half of the oil that enters the ocean is from human sources. And when we look at the pie chart down here that is showing just the human sources, we see that only a small fraction of it is actually coming from the extraction of the oil or from transportation. And these two categories, this includes oil spills, so that's actually a small fraction of the oil entering the ocean. The rest of it is from petroleum consumption. These are called non-point sources, and a lot of this is oil that comes from just runoff from city streets, enters the drainage system and makes its way to the ocean, or oil that is improperly disposed of, like in landfills, which oil does not belong in landfills. Some of that oil, eventually through time, can make its way to the ocean. Now, even though oil spills only make up a small percentage of the overall oil that is present in the ocean, they're arguably the most harmful because there's just so much oil being released in one place at one time. So let's take a little bit of a closer look at oil spills. Okay, an oil spill is going to occur during one of two processes, either during extraction of the oil or transportation of the oil. The largest accidental oil spill in world history was the Deepwater Horizon oil spill in 2010. This occurred in the Gulf of Mexico when an oil rig had an explosion, and that damaged the well on the ocean floor in the Gulf of Mexico, and it just started spewing oil into the Gulf of Mexico for 87 days. And I remember this being on the news, just that webcam of oil just gushing out into the ocean. I say accidental oil spill because the largest overall oil spill was in 1991 during the Persian Gulf War, when the Iraqi army deliberately released the oil from Kuwait's oil facilities and released it into the Persian Gulf. That released 240 million gallons of oil. Now, during transportation is another process that can cause an oil spill. If one of those cargo ships carrying oil runs into an obstacle, that ship can become damaged and start releasing that oil into the ocean, such as the Exxon Valdez oil spill in 1989 occurred off the coast of Alaska. Okay, so what is actually happening when that oil reaches ocean water? Well, initially something called an oil slick forms at the ocean surface. And this is because initially that oil is less dense than the ocean water. So it floats on the ocean surface. Winds, currents, storm, that can start to spread that oil slick out. And the most harmful place it can reach is the coast, where you have sensitive environments such as beaches, mangroves, tidal flats, and that's where it can do the most damage to the organisms that live there. Okay, so once that oil is released, some other processes start to occur that actually start to make that oil break down. One of the first processes is evaporation, where the lighter elements of that oil, it starts to evaporate just like water would, and it enters the atmosphere. Now, with those lighter components leaving, some of that oil becomes more dense, and it can start to sink down into the water column and even reach the bottom of the ocean floor. And so when that occurs, that can be damaging for the organisms that are in the water column and those benthic organisms on the ocean floor. So, what do we do when an oil spill occurs? Well, we do our darndest to try to clean it up. And I'm going to take a pause from our lecture here so you can watch a video on some of the methods we use to try to clean up oil spills. These are some of the methods that you are going to be simulating in your lab this week.